Hello my people. Today we are going to be constructing the unit circle. Now first, before we get there, and of course you've seen the unit circle before, this should be review to you. You know, it looks something like that. What we need to remember is that the unit circle is simply a memorization tool. And as such, it's really helpful. But those unit circle values, sine of these unit circle angle measurements, cosine, tangent, and of course the reciprocals, need to be memorized cold. Now, I am not a huge fan of having students memorize, but this is just one of those things that when somebody says, sine of 5 pi over 3, you cannot be sort of fumbling around. You have to be able to just pound out the answer really quickly, okay? And the same will be true when we get to trig identities. There are just certain things that need to be automatic. And as much as I hate the sort of memorization game when it comes to mathematics, in some cases it's just absolutely necessary. So let's go ahead and get to that construction, but before we do, we need to remember our special right triangles, specifically our 30, 60, 90 and our 45, 45, 90 right triangles. Now the reason that this is the case is those triangles will be inscribed within the unit circle, and it will help us to discern those gosh, I'm totally fumbling today, those ordered pairs that we're going to memorize, and will then of course give us our trigonometric ratios at those common values. Okay, so let's go ahead and let's do our first angle. Let's look at 30 degrees. And at 30 degrees, we're just going to go ahead and drop down an altitude to, or a perpendicular to the x-axis, okay? And once we've done that, we need to remember that this is not just any circle, this is the unit circle, so named because the radius is 1 unit long. Now, that's really helpful because that means that this right here is a unit long. Now, remember that the ordered pairs are going to wind up being cosine, comma, sine. And both cosine and sine have a denominator of the hypotenuse. And therefore, if it has a denominator of the hypotenuse, then sine theta is equal to opposite over hypotenuse just becomes opposite, right? And that's the whole purpose of constructing it inside the unit circle rather than just circle, okay? Now, remember that this is a 30, 60, 90 right triangle. Now, the ratio, as we have seen, is 2 root 3, 1. Okay. Well, the thing is that this ratio of sides is true for any 30, 60, 90 right triangle, which is of course why we were shown this, okay? And because similar triangles or similar right triangles have proportional sides. So instead of 1, 2, and root 3, it could be 5, 10, and 5 root 3. It doesn't really matter. But if we transform this 2 right here into a 1, then we need to cut all of these values in half, don't we? And where we had 1, we now have 1/2. And where we had root 3, we now have root 3 over 2. Now, we notice that this ordered pair is horizontal displacement and vertical displacement, and therefore it is root 3 over 2, 1/2. But that root 3 over 2, because that horizontal displacement represents the adjacent side, according to that 30-degree angle measurement, adjacent over hypotenuse is also root 3 over 2, and that's why cosine of 30 degrees is the same as the x measurement, the x coordinate of that ordered pair. And the same is true for this y. We notice that this vertical displacement, this vertical distance, is that right there, but it is also the opposite side of the triangle from this 30-degree angle measurement, and opposite over hypotenuse is 1/2 over 1, which is why we get sine of 30 degrees. Okay, well, let's go ahead and let's move on to the next one. Okay, and we notice that something similar happens when we drop down this perpendicular to the x-axis. In doing so, we have created a 45, 90 right triangle. Now, remember that when we were dealing with that here, in the special right triangles, it was 1, 1, and root 2. This down here reminds us that those are ratios, hold for any 45, 45, 90 right triangle. And therefore, if I were to transform this root 2 into 1, I would have to do so by dividing by root 2. And so basically what happens is this can become, I'll go ahead and, if this gets transformed to 1, this gets transformed to 1 over root 2. But if we rationalize the denominator, which, we usually do, we get root 2 over 2. And the same thing happens here. Okay? And that is why when we deal with the ordered pair here at 45, 45, 90 right triangle on the unit circle, this hypotenuse is 1, this horizontal displacement is root 2 over 2, this vertical displacement is root 2 over 2, and therefore the ordered pair is root 2 over 2, root 2 over 2. But those values don't just represent the x component and the y component of a random ordered pair on the Cartesian plane. Because they are anchored inside the unit circle, this horizontal displacement right here is not only a this coordinate of the ordered pair, but it is also the adjacent side of this triangle. And adjacent, root 2 over 2, over hypotenuse, 1, is root 2 over 2. Adjacent over hypotenuse is the cosine of 45 degrees. And the same thing is true for this vertical displacement. This vertical displacement, which gives us a y coordinate of root 2 over 2, this length is also the opposite side of this 45-degree angle. Opposite over hypotenuse is going to be root 2 over 2 over 1, that is root 2 over 2, and that is our sine ratio for 45 degrees. Okay, well that's fun. Let's go ahead and drop down an altitude from 60 degrees. And what we will notice is that when we drop down an altitude from 60 degrees, we're simply going to get another 30, 60, 90 right triangle. It's just that those ratios have been reversed, okay? We still have a hypotenuse of 1 because every hypotenuse around the unit circle is a radius, okay? This right here is the 1/2, and this right here is the root 3 over 2. So because this is the horizontal displacement for this point right here, in ordered pair format, it's 1/2, and because this is the vertical displacement, root 3 over 2. But just like the previous ordered pairs that we saw at 30 degrees and 45 degrees, that isn't all that they represent. And of course, that's very intentional. This adjacent side right here, Okay, this horizontal displacement is also the adjacent side to 60 degrees. And just like the last two triangles, because I have a hypotenuse of 1, again, that's why we choose to do this in the unit circle, 1/2 over 1 is 1/2, okay? And that makes this 1/2 the cosine ratio for 60 degrees. And the same thing is true for root 3 over 2, okay? Root 3 over 2, we wind up, root 3 over 2 is the vertical displacement, so it's the y-coordinate, but it's also the opposite side from this 60 degrees. And so sine of 60 degrees is root 3 over 2 over 1, or just root 3 over 2. Now, we need to remember that there also are ordered pairs here, 1, 0, and here, 0, 1. But those aren't really for triangles, are they? Well, you can think of them as triangles. This is a triangle with an opposite side of 0, where the adjacent side and the hypotenuse, think of the 30-degree triangle think of this sort of descending along here and then collapsing into this right here. And we're going to get an adjacent and hypotenuse that are the same value. So adjacent over hypotenuse, if they're the same value, a value over itself is 1. That's why cosine of 0 degrees is 1. Of course, as any of these collapse and give you a 0 angle measurement, you're going to have an adjacent side of 0 and a hypotenuse of 1. And so you have sine of 0 degrees because 0 over 1 is 0. Okay? And of course, the same logic applies up here for when the opposite side disappears, or when the opposite side is all you have and the adjacent side disappears. And so that is why this winds up being cosine of 90 degrees, and this winds up being sine of 90 degrees. Okay? And that's how we construct it. That's why those ordered pairs had the values that they have. And of course, because ordered pairs are simply horizontal distance, comma, vertical distance, but they also represent adjacent and opposite sides, which represent cosine and sine ratios because of our hypotenuse of 1 on all of these triangles. We can use these ordered pairs as a memorization tool for sine and cosine of all of these angle measurements. Now, once we've gotten to this point, of course, we have this in our first quadrant. Okay. Now, this in our first quadrant is really, really nice. We like that. Okay. But of course, we need to extrapolate all the way around the unit circle. And notice on this particular one, 30 degrees has been equated with pi over 6. 45 degrees has been equated with pi over 4, and so on all the way around. And because, I mean, basically those are the same thing. They're just different units of measure. And what we need to do is we need to always remember that when we are dealing with an ordered pair on the unit circle, that not only do these represent cosine and sine, but they represent horizontal and vertical distances, because that's going to turn around and help us when we're dealing with inverse trig, especially when we're dealing with inverse trig as an operation in solving trigonometric equations, and not simply in terms of inverse trig as a function. Okay, and you'll understand more about that when we get there. So when we actually extrapolate all the way around, we get something that looks like this. Okay, and I'll go through and explain this just a little bit more. But basically, notice that all of the points that have a reference angle of 30 degrees all have the same x and y coordinates, with the exception of positives and negatives, right? So 30 degrees is the same reference angle as 150, right? Reference angle being the distance that it is to the closest x-axis. And 210 and 330. Those four angles all have the same reference angle. And notice, if we zoom in just a little bit, notice that they all have root 3 over 2, negative root 3 over 2, negative root 3 over 2, or positive root 3 over 2 as their cosine angle. And they also have 1/2 or negative 1/2 as their y-coordinate. That is not accidental, because remember, those are xy coordinates, and if you have the same reference angle, then you have the same absolute value, you have the same distance from the x and the y coordinate, but in the Cartesian plane you simply have different positiveness and negativeness depending on which one of the quadrants you happen to be in. Now let's move on to 45. 45 is the same reference angle as 135, and the same reference angle as 225, and the same reference angle as 315. That means that it is absolutely no surprise that root 2 over 2, comma, root 2 over 2 recurs on all four of these, just changing sign, S-I-G-N, right? Positiveness and negativeness. It changes positiveness and negativeness as it goes around based upon which particular quadrant it's in, but it still has the same distance. And of course, distance is always positive, right? It has to do with the magnitude, the absolute value of a number, and not its direction, not its positiveness and negativeness. And last of all, just to drive the point home, if you have 60 degrees and 120, and 240 and 300, all four of those angles have a reference angle of 60 degrees. And therefore, they all have the same distance, the ordered pair that is right here, right here, right here, and right here. All four of those have the same distance from the x-axis, and they all have the same distance from the y-axis, which is why if we ignore positiveness and negativeness, they are the same ordered pair, and we just have to adjust the positiveness and negativeness with respect to the particular quadrant that they are in. Okay? And of course the special cases of 0, 90, 180, and 270, and those can be reasoned out in terms of kind of pseudo triangles that have either an adjacent or an opposite side that has collapsed upon 0, and the other side, of course, has collapsed into the radius, has collapsed into the hypotenuse. I hope that actually walking through this, and it's if you understand the unit circle already, it's probably pretty torturous to watch somebody construct it yet again. But I find it helpful to remind students of this, that the whole magic of the unit circle is that xy coordinates also, which of course are distances that are registered from the x and y axes, those xy coordinates also double as adjacent and opposite sides, where a hypotenuse is 1, and therefore they give us those ratios of those common angles. Okay. As we proceed, I won't do this over the summer, but as we proceed into the early part of the fall, I may give you, here let me zoom out just a smidge, I may give you unit circle quizzes, just to give you, all teachers like to encourage their students, and when we're incapable of encouraging our students with the carrot, we encourage them with the stick. Unit circle quizzes might be given. They will be timed. If you do not know your unit circle cold, you will not do well, okay? There will be certain things that I expect you to know that we will not go over explicitly in class as we move forward. And those things will start being collected within the cumulative quiz channel on our team, okay, on our calculus team. And those are the things like trigonometry, like some of the topics in trigonometry, there are other things that are foundational and are your knowledge of them is assumed when we start doing the calculus. And I will give you the extra added incentive along the way to keep up with those things and keep them fresh in the forefront of your mind. But the unit circle values will be one of those things that I expect you to know just cold. Okay, you need to know these values cold, and you need to be able to give them to me at the drop of a hat. That's it. I know that you were hoping for more than a single video, but alas, there's really not much to discuss in terms of unit circle values. We will get into some of the trig functions and stuff like that when we get into 4.3 and start taking these things and applying them to right triangle trigonometry. But I hope that is helpful. Please, as always, do send me a chat message if you have any questions, concerns, queries, anything like that. Bye.